Now, we are going to practice our exponent laws that you learned in grade 9. And under each of these, I'll give you 2 of them to try. An easy one, a fractions one, and then a fractions and variables one. So here's our easy one. What is 3 to the 5 times 3 to the 7 equal to? Here is our fractions one. What is 5 to the half times 5 to the 2/7 equal to? And here is our variable one with fractions. What is x to the 1/3 times x to the 4 equal to? They all follow this rule because this rule says if your bases are the same, and you have a power with the same base multiplied by another power with the same base, you can just add the exponents. So did you get the easy one right away? 3 to the? No. Look how if you think, okay, this is the one that you really have to understand. Why is it not 9 to the 12th? Because 3 to the 5 means 3 times 3 times 3 times 3 times 3. And 3 to the 7 means 3 times 3 times 3 times 3 times 3 times 3 times 3. How many 3's are all multiplied together? 12 of them. Is there 9 multiplied together 12 times? No. Can you see that this is 12 3's? Not 12 9's multiplied together. But you are going to be tempted, because you see 3 times 3, to write 9. Okay? Now, you might be less tempted here because you can visualize it. But you really, really, really have to understand the easy one, because you might be more tempted to write 25 in the second one than you would be in the first one, because the fractions will throw you off. How do you add fractions? You need a common denominator. Did you see that you should change the half to 7 out of 14 and the 2/7 to 4 out of 14? And get 5 to the 11 out of 14.
Oh, I was over 3. But basically, 11 over 14. Yeah.
Okay. And then with the variable, the bases are the same, so this will be x. And this is 1/3 plus, and you need a common denominator to add fractions. So 4 changes to 12 over 13. 12 over 3, sorry. And so you get x to the 13 over 3. Rule number 1. Rule number 2. Okay. Start off with an easy numbers one. Then go to a numbers one with fractions. And then go to a variable one with fractions. So again, the first one is the one that is going to be like, you should think of easy numbers when you're trying to remember your exponent rules. This is equal to 7 squared, and it's easy to see that.
Oh, you have to,
Because this is what it means, right?
minus, basically.
You have to minus, but why do you have to minus? Can you see that if you were dividing, these would all cancel out? 6 of them on the top with the 6 on the bottom. What are we left with? two of them on the top. Does the exponent law make sense? Okay, it's with the easy numbers that your exponent law will make sense. But then, once you have the exponent law making sense, then we have to start doing it with not easy numbers. So this one should equal 4 to the 1/3 minus 5/8. What would be our common denominator? 24. So this is 8 on 24 minus 15 on 24. Giving us negative 7 on 24, or you could write it like this. With the negative exponent rule coming into effect as well. So the blue one that we did at the beginning and the green one we did second are the same rule, but we have to remember all of our math from previous comes into play. Like you have to know your fractions. You have to know your exponent rules. Here we've got the negative exponent rule. And the last one is 1/9.
Oh.
Not 119.
Oh. Come on.
Otherwise that would be a very big number. So 3 is 9/3. No, sorry. 3 is 27/9 minus 1/9 leaves me with x to the 26/9.
Okay, so basically you would do the 3 times 9, which is 27,
Mm-hmm.
and then you have the 27. That's how you got that?
Well, because it's 3/1, right? So technically what you're doing when you're getting a common denominator is you're like, I want the bottom to be 9, so I'd have to multiply the bottom by 9, but then I also have to multiply the top by 9. You're technically multiplying by 9/9, which is multiplying by 1. When you multiply by 1, you don't change your answer, but you can change what it looks like. And that's what the 9/9 is doing. It's changing the 3/1 to 27/9. They're still the same number, they just look different. But the 27/9 is helpful because then we can subtract. All right. Exponent law number 3. There's our number 1. Here's our fraction 1. There's a variable 1. This is our power of a power law. So the rules, oh, I've got to give you a little bit of time to practice.
Yeah,
I'm just so excited to say that.
Is that a 3 or a 5? The 2 over something else?
2/3.
Oh, okay, that makes a lot. Yeah, I was counting for a long time.
And Lennon, you can use a calculator for the test if you need it. You're allowed a calculator. Okay. Okay, let's see how you did.
No.
Did you get
I'm trying to do the multiplications.
3 to the 10?
Yeah.
And again, with the regular numbers, it should make sense to you. Do you know that 3 squared means 3 times 3? Right? And the exponent of 5 would mean that I would have 3 times 3, 2 times, 3 times, 4 times, 5 times. Does it make sense that you have to multiply? Because you have groups of 2 of them 5 times, 2 times 5 is 10. That's why we multiply. So all of your exponent rules will make sense if you go back to easy numbers and think about what an exponent means. But we have to make sense of them here because it's hard to visualize 6 to the 2/3 to the 5/7. Our brains can't quite do that well. But this is going to be 6 to the, how do you multiply fractions? You multiply the tops, you multiply the bottoms, so you would get 10 over 21. And a little bit of a review. If I wanted to write this as a radical, what could I do? I could write this as the 21st root of 6 to the 10. Right? Because the number on the bottom can be changed to a radical. And the last one, x to the 8 to the 3/4. 8 is 8 over 1. How do we multiply fractions? Multiply the tops, multiply the bottoms. Okay? Two things you can do here. You could multiply the tops and get 24 over 4, and then simplify that to get x to the 6. Or you could look at this and say, hey, I already know that 8 divided by 4 simplifies. 8 divided by 4 would simplify to just be a 2 on the top. And then what do I have left? I have 2 times 3. That also gives me 6. How do you multiply fractions? 2 times 5 is 10. 3 times 7 is 21. Yes. Power of a product. This one is easiest to see at first if we do a number and a variable. If I have 2x to the 4, what is that? What is that equal to? Then I'll do one with fractions.
2 to the 4 and x to the 4. Oh, wait, sorry.
And then my last one, I will combine some. So according to the rule, if you're multiplying inside, this would equal 2 to the 4 x to the 4. And sometimes if you get a number like this, 2 to the 4 is 2 times 2 times 2 times 2. You could simplify that and say, I know that that's 16. That's 16x to the 4. It's with the easy one, the green one, that you can see why this works. Why does the 4 go both to the 2 and to the x? Right? If you're just memorizing a rule and you don't have a reason why, chances are you're going to make more math mistakes once the questions get a little tricky, or even if they don't get tricky, chances are you're going to make more math mistakes. So why does the 4 go to both of them? Well, again, if we think about what an exponent means, an exponent of 4 means I would have this 4 times. Can you see that you have the x 4 times and the 2 4 times? It should make sense that you would have 2 4 times and x 4 times when we multiply it out. Because when you're multiplying, order doesn't matter. I could have rewritten this as 2 times 2 times 2 times 2 and then put my x's at the end and have 2 to the 4 and x to the 4. again, what we're doing here is we're reviewing our grade 9 exponent laws, but while we're reviewing them, we're trying to realize why they make sense. Because they don't make sense as much when you go to fractions and when you go to lots of variables. So we need to have them make sense here so that we're able to do them in the more complicated situations. So the second one is just a to the 1/3, b to the 1/3. The third one, 16 to the 1/4, x to the 2/4, y to the 3/4. See, the 1/4 went to all three of them. And then here, you'd ask yourself, is there anything I could simplify? Oh, the 16 to the 1/4 is the 4 through 16. You're right, that's just 2. The 2/4, someone said. Yes, we could write that as a 1/2. That would be a simplified version of that answer. And it's important that you understand the rules, and sometimes it's important that you understand the words. Notice that it says power of a product. Number one mistake that often happens is with this one. What do you think people want to write as the answer for this one? The people that get it wrong. Can you predict the wrong answer here? Close. The most common wrong answer for this one is?
X plus y squared?
Yes, this is wrong. I'll write it in red. This is wrong, so you don't get confused. They write x squared plus y squared. Why did they get it wrong? Because they're using this rule in the wrong spot. This is a power of a product, which means this rule only works if we have a product. Because if you have a sum, because x plus y is a sum, what does this actually mean? Well, if we go back to our definitions, this actually means x plus y, x plus y. How do you multiply x plus y times x plus y? You have to FOIL. The first one would be x squared. Outside and inside will give me 2xy's, and the last ones will give me y squared. So the x squared plus y squared is close, but completely wrong. Can you see yourself making that mistake, right? Because you're like so tempted. And this is, I mean, math is very powerful, but very easy to play tricks on you. Because sometimes teachers do stuff like this, like, oh, you just put the 4 to each one. Doesn't that look like distribution? But it's not distribution here, because you're not allowed to distribute it here. So we sometimes, when we learn so many different ideas in math, sometimes our brains want to like, oh, I'm going to steal this idea over here and do it over here. Well, that's not necessarily allowed, right? For example, I'll show you a really good example. What would be a good example? Oh, this will be a good example. What is the square root of 2 times the square root of 8? It's equal to the square root of 16. Perfect, which is 4. So you were able to, if I had put a little space here, to figure out that in that space was 16. Correct. Okay. Square root of 2 plus the square root of 8.
It's flat.
Yeah, plus. What number goes in the green line?
2.
You have square root of 2 and you add something and this doesn't matter and it's still square root of 2?
No.
What does your brain want to say? 10, right? And you know that you're falling into a trap. I've set up a trap for you on purpose. Okay. You want to say 10. Okay? It's not 10. Now let's start guessing. It's not 16. No, it's not 12. No, it's not 4. It's not 5.
6.
It's not 6. It's not 24. Come on, we can get it eventually. If you keep guessing, it's not a decimal or anything, it's a nice number. 2? It's not 2.
8.
Not 8. It's got to be bigger than 8, it's got to be bigger than 2 because you're adding. Not 11.
12.
No.
16.
No.
18.
There it is. Oh, you guys are geniuses.
Woo! I'm so smart.
You're so smart, right?
First try.
First try after 17 mistakes. Good. Perfect. Does that make sense to you?
No.
Good. It shouldn't. It looks terribly confusing because it doesn't seem to match up.
But if you see
This seems to make sense with your brain. It's like, oh yeah, square roots, you multiply. Seems to make sense. Because it's like, this looks like regular math. This does not look like regular math. And as we get into more complicated math, math does that. Now, if I show you why this works, you'll be like, that makes sense. For example, please fill in these blanks. I'm rewriting, instead of root 8, what could I do? That'll be 2 and 2. Good. All right. And if I rewrote 18, oops, there we go. What's another way I could write 18? 3 and 2. Perfect. Okay? Now I'm not going to tell you any more than that, and I'm going to give you the next puzzle I need you to solve. What number goes in there? The hint for what number goes in there, instead of guessing right on the first try after 17 mistakes, right, because we could probably do that again. We don't talk about the 17 mistakes. We don't talk about Bruno either. Okay, so, can you see here in the hint how to do this? This is, right, root 2 plus root 8 is root 18 is true. It's the same as saying root 2 plus 2 root 2s equals 3 root 2s.
45.
45. First guess, no mistakes. What did Cass do?
20 times 2 plus 5.
20 times 2 plus 5.
I mean, I'm not wrong.
But that's not the why, it works. What did he do to the root 20? What do you think he did to the root 20?
Wizardry.
I'm thinking he did this to the root 20. He said root 20 is 2 root 5s. And then I'm thinking he said, well, what 1 root 5 plus 2 root 5s is probably how many root 5s? 3 root 5s. And 3 root 5s is the same as root what times root 5?
9.
And then I think he got to the 45.
Oh, so 1 plus 2. So 1, 2, 3.
Okay? But what we're seeing here is that your brain wanted to just say root 10. Life would be easier if it was root 10, if you just could add. But math doesn't always work that way. You want to do one more of these to see if you can get it? Okay. Let's do this one, I'll do two of them. This one's too easy. That one's too easy. But I'll leave it for you. I will give you, let's do a root.
48. Is the first one 48? Then what do you do after?
Let's make it a little bit bigger here.
Is the first one 48?
Whew. That's bigger. There we go. Yes, you're right. The first one is 48.
Yeah.
People are not real. People are not real. She's like singing and doing.
All right. Here's a big number.
Nope, not that.
I got 507. Yes. Yeah.
I think you would be.
Because this is 3 root 3s,
Yeah.
and this is 10 root 3s,
Oh.
and this one happens to equal 13 root 3s. Perfect. Okay. Sorry, I got distracted. I got distracted because I wanted to show this common mistake, and sometimes if we don't understand a rule and why it works, our brain will just start saying, hey, try this rule here. Should you try it? And you're like, I don't know. And your brain goes, well, then let's do it. Because we don't know why we're doing something. And that is a recipe for making mistakes.
So what does what we were just doing have to do with power of the product?
What we were just doing got us, I know, I went off on a little bit of a tangent. What we were just doing was connected to this common mistake with the power of the product rule. And then I showed you another place where your brain might want to make a common mistake. That's where it fell off. Yeah. Here we go. Quotient, power of a quotient.
Is anything like what you just showed us going to get on the test?
On tomorrow's quiz? Tomorrow's quiz is up to page 9. What page are we on?
Page 19.
No. We're on page 19. What we're doing right now isn't on your quiz tomorrow. I mean, the review that we did at the beginning is stuff that's on there, right? Number families. Oh, did we even finish the review question? I didn't do this one. What number families does square root of 16?
No,
It's a natural number, it's a whole integer, it's a whole number, it's a real number, and a rational number.
yeah, because that's what I was doing. Hang on, can you,
All right, we're going to end here. We'll leave the power of the quotient for tomorrow.
hold on.
Definition of natural, 1, 2, 3, 4, 5, 6, 7. Include zero, and you with zero, positive and negative whole numbers and zero.
But isn't that what holes are as well?
But holes doesn't have negative numbers.
Oh.
She's really like drilled on it. I'll never forget Sir John and
Yes. What's that? A lot of people like to use them for pre-calculus and applied math.
Yeah.
You can type